Well, good morning, everybody. All right, here's the quick setup for today's forecast video. After we get through the kind of typical cadence of looking at the weather over the next couple of weeks, trying to diagnose where things are going, I'm going to shift my attention back to that long range again because we have another June update from the European model that's very consistent. And I'm looking for if there's any sign of trouble happening with both global momentum and also with the ocean temperature patterns, which are related. So I'm going to cover that at the very end of this forecast video, plus a little bit of an international update. But I am working on something for you. Many of you have asked me why we've been so windy this spring, and we've talked in these videos about how spring of 2025 has been one of the windiest springs in the last 50 years, if not the windiest. And I want to get a good explanation into a forecast video to kind of explain all that to you. So I either have it for you by Friday, or I'm going to work on it for early next week. But I want to be able to give you a real good answer, something that you can take and understand, and if anybody else asks, you can explain it to them. But the reality of it is that since about March, we have seen two different types of storm systems. Coming back into March, we saw many of these deep upper level lows that were connected to the jet stream flow that started in the Rocky Mountains after coming through the western United States and just blasted their way east. They were fast. Those are the ones that created those huge dust storms that we watched coming out of New Mexico, Texas, and parts of the southern plains. Okay, since then, about, I don't know, those lasted for about a month. Into April, we saw several of these. Again, they look like giant lows. They are. But the difference has been the upper level flow. All right. We've not had the same sort of speed, the continuity in the speed, starting all the way from the Pacific, maybe over by Japan and finishing in Maine. And instead, the upper level flow has been much weaker, more displaced, but these cutoffs at times have come through. This one was not cut off, but they've come through much slower, but they've been able to deepen the pressure field. I want to do a better job explaining that to you, because once again, we saw this one mature last night, and a lot of severe weather was the result of this one. But as I was watching through this satellite animation, I thought there was a couple of very fascinating things about the atmosphere that I think are worth talking about here. So let me take you to down south. So here we are into Texas. So you can see the tail end of the front. There's some of the deep convection, but the atmospheric scientist in me likes really to think about this. Now, as you look at the image, can you see the difference between the coastal parts of Texas and the interior? There's clearly something going on here, creating a pretty deep haze in the atmosphere that the satellite visible channels are picking up on. And what's going on here is this. Let me take you to an image that shows you the dew point temperature from yesterday at this time. It looks something like this. So what you've got here is where the moisture from the Gulf has been opened up into the United States, and there it is, all right? But there is a continental air mass, one that is dry, that has kind of pushed its way out of the desert southwest, out of the central plains, and it's butted up against this area right here. Now, sometimes that particular boundary is way back over into Texas and Oklahoma, Kansas, Colorado, and we call it the dry line. In this case, this dry feature, this dry line, has pushed its way pretty far to the east. But this is what happens. The dew point is high, the moisture content is high, the humidity, specific humidity, is very high. And you've got a lot of impurities in the atmosphere. This is natural. In fact, if you don't have those impurities, you can't make clouds in the first place. Did you all know that? A pristine atmosphere, one that just has air and no aerosols, no dust, no soot, no ash, nothing, no sand or salt, anything, nothing floating in the atmosphere. You get no clouds. It's hard to get vapor condensation, right? To break it's a Gibbs-free energy barrier. It's hard to get condensation without a nuclei. And what's interesting about it is there's abundant amount of it right here. Some of this has been dust and sand and stuff that's been picked up from the continent, pollutants, aerosols, whatever. It's all in here. And then you also have salt from the ocean, okay, that's in the lower atmosphere. But that boundary right there where the humidity is high to this direction and low to that means you're getting some activation of those nuclei, those impurities. Now, what's activation? You're getting vapor deposition on them. In other words, they're trying to grow in size with water condensing, and that's what creates the haze. That was fascinating because it's so easy to see on this particular image. Now let me take you to another spot. We were watching deep storms once again curl up in the central U.S. Watch these storms roll right through here. And this is following about a week of incredible severe weather. There's no way for me to spend enough time telling you about the depths of the severe weather. And and its impacts. But I was fascinated by one thing, because after these storms went through last night, very close to where I live, right here in East Central Illinois, which they did some damage. This was some of the hail. That's my hand. Out on my front porch, we saw hail. A couple of them were up to about golf ball size here. Those storms last night were quite good at producing that. But after those storms went through, and boy, did they do quite a bit of damage. Take a look at this. This is the reports from the 18th. Remember, I couldn't get these to upload the other day. There's the 18th. 43 tornado reports, 330 in total. Here we go into the 19th. This is another 23 tornado reports, 557 in total. And then this was just yesterday. There's the hail reports that I just showed you here. We even had a couple of tornadoes spotted in the area. But look at the Mid-South, the Tennessee and the Ohio Valley. Once again, just a lot of severe weather in this. In fact, real quick before I finish this story, this is where we currently stand on tornado counts. Average is 653. We're at 883. If you look at the hail reports, we've jumped way above average by about 500 more reports than our historical average. But take a look at the wind. 2,871 reports is normal. We are at 6,317. And that's, again, why we're going to have this dialogue either Friday or early next week about what's going on with the wind this spring. But I want to show you something, because after this storm went through and gave us this hail, my wife and I just went for a walk last night. We try to do that every night. And as we were out, I want to show you something that I saw. Now, this is just in the neighborhood around where I live, and that is an interesting feature. So what are you looking at here? Well, the flat top is familiar. That is where the updraft, has gone up and hit the stratosphere. All right, so the stratosphere is here, the troposphere is down there. So when it hits it, it spreads out horizontally, stops the vertical motion because the stratosphere is statically stable. It's stratified. It can't get through it. But what's interesting is this is not connected to anything. Okay, this is out ahead of the bigger, deeper convection farther back to the, in this particular case, you're looking toward the south and west. And what I found fascinating about that was, I'm going to show you what I saw. Now, this may not look like much. You're going to have to come in here and try to find this with me. But I am basically right here. That is where I am. I'm in between these clouds last night, where I took that picture looking in this direction. I'm sorry, so I was looking southeast. If I said southwest, I'm sorry, I was looking to the southeast. And this is the abandoned updraft with the deeper convection on the back side of it. Now, I didn't open up the picture wide enough so you could see these huge storms, but I want you to watch right there, okay? Now, as we play this forward, there goes that little abandoned updraft producing that abandoned anvil cloud right there that I took a picture of. And sometimes they just don't make it. And that's one of them. I know it doesn't look like much, but it was neat to see last night. And we watched the deeper storms move over to Indiana. And again, just a lot of severe weather. So I thought you might find that fascinating. That's what you can see there. There's those deeper storms moving into Indiana. The bigger ones are even off the image. They're farther over here on the left-hand side of it. Okay, we put it all together and we just think about what's happened over the last week. We have had across parts of the Dakotas, some places 10 times the normal rainfall that they get this time of year. But the storm system did run through a very dry section of the country. In fact, this only goes up to yesterday morning. If we add in what happened since then, you can see that hitting parts of Minnesota, Iowa, Wisconsin, Illinois, Indiana, and parts of Michigan, this was needed rain, very much needed. This was not. Okay, this was needed, this was not. But if you just come back, we're going to try to figure out later on, does this area continue to grow? What happens throughout the south and southeast? How does the western United States respond to the potential for larger ridging events this summer? Should they be here or if they're in the midsection of the country? That's where I'm going in the long range here in just a few minutes. But first, I do need to mention that this is an interesting map, but there was some snow that fell last night, as the models did a pretty good job predicting. This is just the 6-hour snowfall analysis. And so this is just from midnight through this morning, and there you can see some of that snow in this area. Okay, where are the storms this morning? They've moved through parts of Alabama and Georgia, and we've also gotten them offshore here in North Carolina, so things have kind of cleared out. But I was looking at the wind field this morning and just wanted to pay attention to a couple of things. There is a boundary in through here we're going to have to pay attention to, of which we have a low that's kind of curling up right there. That'll be an important story for the severe weather risk in this area of the country today. But that deeper low that just moved through, it's sitting over here. But this was what was fascinating to me. there's actually a low, another one of these little interesting cutoff features, that is completely surrounded by higher pressure. But it's very tight. It's a unique view of a low. Normally they dominate the wind field and the high pressure's not sitting around them, but is displaced to one side. So just kind of a neat view of a low pressure center sitting in the midst of higher pressure that surrounds it. So as I mentioned, that frontal boundary today, plus the little low that's sneaking in through here, is going to give us the severe storm risk. That's going to be in a pretty narrow corridor as much cooler air and dry air has worked its way into the north. These storms have already cleared the southeast coast, so we can just see where SPC was putting out its risk for today. Here's tomorrow. We kind of have that Loch Ness Monster view of the outlook of the next round of storms. And then we get into day 3. Again, some convection in the Central Plains. But in order to get this, we're going to come back to something I talked about earlier in the week. We've got higher pressure here. So we're just kind of getting flow around it, which is putting the squeeze on the atmosphere right into this area. This morning about 6 a.m., this is our all hazards weather map. We have the frost in a few key areas here. This one north of Spokane. We have the end of the Snake River Valley here. Then parts of Minnesota, northern Wisconsin, kind of this North Woods area that are under the frost. We have flood watches that are still out here, and our flooding that's ongoing throughout the Mississippi, lower Mississippi Basin, mid-Mississippi Basin you see there. All right, so let's kind of get an idea where it's going to head. This is just precipitation type and intensity. We're starting this up at 8 o'clock this morning. The low moves its way into the northeast. There it goes, and it's going to be bringing widespread cloud cover, rain, cool conditions into this area. This is later on this afternoon, this evening, tonight, where we're going to be watching the risk of those severe storms, as you just saw a moment ago. And then we're going to press this into early Thursday morning and get us out there through Thursday afternoon and evening. Now, what you're seeing in the northwest, that was that cutoff low that was here, making its way through Oregon, Washington, parts of Idaho and Montana. It's going to sit up there and spin pretty far to the north. But this system has scoured out all the moisture, so we're not expecting much out of the one that follows. So that gets us here. We've got ourselves 5 different models trying to predict the next 7 days, and you can always access this on agweather.com. I'm going to particularly focus in on this one. Let's just open this image in a new tab real quick. It's the WPC forecast. And again, we see parts of Kansas, Missouri, into the mid-south looking extremely wet. And this is an area that has been very wet, as you saw a few moments ago. So to continue to see very wet conditions in this area is going to be problematic. We're a bit drier farther to the north of it. There is still a bit more moisture coming into Nebraska, which, again, we've been monitoring the depth of the drought there lately. And you can also see into the northeast. We've got pockets from West Virginia, Pennsylvania, New York, all the way into the interior states here of 1 to 3 inches of rainfall coming out of this. To have a look at some probabilities, though, just want to show you where we're going to go over drier. Take note, if we start east of the Rocky Mountains, there is a broader area that's drier here and in through here. Okay, there's just this little squeeze that's put in the atmosphere right in the middle where there's better chances of rain. The map is the probability of staying under a half inch. A lot of the Canadian prairie is drier, but this as well. You can see so is parts of the southeast. Now into the southwest, when you start to see this time of year, this is just common. Until the monsoon gets going, we tend to be very dry. So if we flip this over to who's wet, and sorry, once again, let's just get that new model run out of the way. There you are. That's the probability over the next 10 days of grabbing an inch. And if we step it up again, this is the probability of 2 inches. So we're watching very carefully this corridor for the continuation of very, very wet weather going forward. All right, so let's kind of get an idea on the timing of this. So I have over here on the left the GFS and the right the European. Skill scores, GFS has dropped off once again, not as bad as it had been, but it is off. This is getting out there to Thursday into Friday, so that's when that next low comes in as one leaves. We're going to watch as we go from Friday into Saturday. Again, see what the boundary is. What's causing this is this squeeze that's getting put on the atmosphere between a large area of high pressure here and just weaker low pressure right over the panhandles. And that's what's giving us this front right in through here on which we're expecting more rain. So that's that corridor we just mentioned. And again, this is Saturday. Getting into Sunday, here we go. That's Sunday morning. This is getting into Sunday midday. I'll be watching this carefully. I mentioned this, I think, the other day. I love going to the Indy 500. I'll be over there. It's going to be great. I kind of sit just as you come out. I actually sit right where the pit entrance is, but on the west side of the stadium. And so I can't wait. But my friends I'm going with are like, give me the forecast. I'm like, all right, we're doing okay right now. I think we're going to be all right. Both models are dry. Sorry, a little bit of a diversion there. But we can see that as we get into this weekend, there is a low that's going to be moving through the Midwest again. The models are not settled on where it's going to be. And I'm just going to tell you again, the skill scores of the GFS are lower than the European are right now. So we'll need to watch this carefully. This is just early next week on Memorial Day, what the precipitation pattern looks like. After that, though, we do get this setup in the atmosphere where I think more high pressure builds in. Now, I'm going to be honest. When you look out here and you see that the GFS keeps a low and the European has almost the exact opposite with a big area of high pressure coming in, it's got me wondering what this real week 2 pattern is going to look like. So I'll use the ensembles to try to figure this out. Because as we go forward, there's that low I just mentioned. This is by next Wednesday. Overall, I would suggest that if this pattern really does get into some configuration like this, there should be a larger section of the northern tier of the United States that's drier, like the northern half of it, with only wet weather hanging around kind of east. We should expect quite a bit of heat in the west with this, very hot conditions to finish out the month of May as the jet kind of rolls back over the northern tier of the U.S. You can start to see that in the forecast models. Again, there's the GFS solution for week 2. Here's the European. You can see that the CPC is really kind of siding with the European pattern overall. If we kind of blow that up, again, there's that drier look into that area. Okay, so let's just take it as it is, knowing the pattern looks like this in early June. And then let's look out here at the temperatures. There's our frost risk map over the next 7 days. We talked a lot about this on Monday. Let's go ahead and have a look at those high temperatures. That is not the right animation. Let me open up the correct one for you. So if we slide down here, there it is, sorry. This is the correct animation. That's today's highs, getting into tomorrow. Look at the cold air tucked into that trough. Holy cow. We then get out there to Friday. Look at the heat coming off the front range on Friday. This is how things shape up on Saturday into Sunday this weekend. So look at the coolness coming in behind this. The heat in the west. There's Monday, Tuesday, very hot throughout much of the western United States. And that seems to be where the pattern's going to keep us day 5 through 10. So we have the end of this cool round of air moving out by the end of the month. And then as we start the month of June, this is the first 5 days of June, we see much broader warmth that's still being forecast in the models. So that gets us to the long-range discussion. So here we go. I've now shown you, and Matt has shown you for the last 7, 8, 9 runs, that the European model keeps doing this. It keeps giving us this longer wave pattern with dryness running north-south throughout the plains. And again, that same dividing line seems to be right in through here. On the temperature side of it, I don't think I'm going to surprise anybody that the 30-day anomaly for June looks like that. A lot of heat in the plains, some heat getting into the western Corn Belt. The model's been stuck on this for a while. And we've tried to make a case for why it is. Is it that, the MJO, we looked at the 100-day low pass forecast by Paul Roundy and made some sense out of these longer waves that are expected to be. I've talked about momentum. I've talked about all sorts of things. And I can try to explain it away in 1,000 different ways. But sometimes the model trend is worth just paying attention to. And you've now seen it do something like this for a while. I'm really trying to understand, though, one big thing. If we are going to see real risk of drought redeveloping in places that lately have had plenty of rain, it's going to be about the positional shift of one of these two things. There's one, there's the other. Since the beginning of May, the Pacific high has sat here in the low levels of the atmosphere, and the Bermuda high has been there, just ever so slightly displaced, not much, but into the North Atlantic. So this, again, is low-level height anomalies, pressure fields, what we're talking about here. And here's what would be maybe the worst case scenario if you're in the central United States, a good scenario if you're on the coasts. If this drifts off in this direction, and this drifts off in this direction, we will leave in its middle a big area of high pressure there. And if that occurs, we'll be wet east, we'll be cooler compared to average. It's still hot in the summer in the west, but we'll be cooler with more storms west, active southwest monsoon. That's been this narrative we've been carrying for a while. So a lot of that narrative is going to come down to understanding the atmosphere's influence on the ocean temperatures. And we're in the middle of this 40-day assignment of watching this region, right? That's our PDO region. The PMM, which is in through here, is already negative. If these water temperatures drop, which over the last week, there's been some cooling. There's actually been quite a bit of warming there. But if this stays hot, I'll put a W over it, and that goes cool and cool. The risk of having heat and drought in the midsection of the country goes up. That's our narrative we've had for a while. So if we're paying attention to those high pressure cells, let me just start you off with, week 2. This is day 7 through 14. You can see compared to average, we've moved higher pressure there, and the Bermuda high is expected to drift a bit. And that's why that week 2 pattern is a bit drier. What I want to know is, as we keep sliding this 1 week sliding window more into June, where does that Bermuda high go? By mid-June, okay, the height anomalies are taking the greatest pressure difference and shoving it pretty far into the north. Now listen, if you would have seen these back into here, all I'd be talking about is nonstop thunderstorm action in this area. Okay, that's the Bermuda high in its position. Now you notice, like, wait a minute, but I see lower pressure. I understand. This is summer. You can get that. But if that Bermuda high ends up drifting, we've got something to talk about with respect to just shutting all this rain that we've seen off. Now, I'm not saying that's going to happen, but that's why the model's doing it. You see it's drifting. It's over here. That's why this whole region shows up drier in the models. We're continually stopping, I guess you can say, the flow from the Gulf into the midsection of the U.S. All right. So you know that there's a couple of bigger picture things we watch to understand this, and I've made a case that the ocean temperatures often advertise in a much easier way what the atmosphere is up to. So one of the things we look for is the PDO. That's the cold water that could surface here when the PDO is negative. Now, I don't know. Let's go back to let's start here. It's clear, right, that when we have PDO that drops, like there's 1988, for example, or when it rises, there's 1993, we tend to see midsummer precipitation anomalies get quite large. So just to keep our ideas on this, I don't know, here's 10, 11, and 12, negative PDO. Then we get into 13, 14, 15, 16, 17, where the PDO was positive. And then we started to see some drought reemerge at times, right, in the last 5-6 years in the plains, in the western Corn Belt, sometimes in the eastern Corn Belt in the middle of summer. And that's when the PDOs dropped off again. And we're right here right now, okay? The latest April value is negative. And so what I'm curious about is when we get the May and June, do they start coming back down like this? And if they do, that is a signal that the coasts avoid the heat drought stress and the central U.S. takes it on. Now, what's the point? From June to August, historically, the Pacific high sits here and the Bermuda high sits there. That is average. Okay? What this does is flow comes around, flow comes over the top, and it storms in the middle. That's normal, okay, if you want to say what average is. If you look at the correlation in June through August with the Pacific decadal oscillation, when it goes negative, the Bermuda high isn't here. It shifts up toward like Nova Scotia, sometimes in really bad years, all the way to, Iceland or Greenland. I'm sorry, Greenland's here. Iceland or Ireland. Ireland's green though, right? But anyways, it moves. And then the Pacific high builds into this area. That's what tends to happen. Now that's the low level high. The upper level pattern, there it is, Ridge 1, Ridge 2, Ridge 3. So that's why we're watching those ocean temperatures. There's another component to this though, right? This PMM, the cold water that's here. When you look historically at that, what you tend to get is not this map, but this one. The Bermuda high, in that case, tends to drift way far into the North Atlantic. We end up developing a lot of low pressure here. In the middle of the country, there's high pressure, and the Pacific high wanders off in this direction. This is what gives us that cooler look along the west coast. The upper level high pattern is, ready, 1 ridge, 2, and 3. So that's why we're paying so close attention to these ocean temperatures. And I think that's where a signal could come from if we're going to see it. So again, I'll monitor it every day. You can go to Tropical Tidbits, by the way, and look at these maps anytime you want. If this goes cooler, this stays cooler, and this goes warmer, that's a signal we need to pay attention to. Now, later, we're going to turn all of our attention to the Atlantic and these ocean temperatures and what they could mean with respect to, the hurricane season. But speaking of tropical moisture, I do want to show you this to finish us out today. This is the current look at the flow and the low levels of the atmosphere. And the building in of high pressure right here, okay? this flow that you see here. Now it's kind of hard to denote what the actual pressure is because it's right on the equator. But anyways, you see around it, we're actually starting to get a very early and active start to the Indian monsoon. And over the next 10 days, look, I just want to show you something. If we look at temperature, see the coolness here? This is indicative of the cloud cover, the moisture that's coming into that area. It's still hot now around the Black Sea after what was a 10-day cooler time period. So you can see the temperatures really jumping up there. But take a look at the precipitation patterns. Very, very wet in this part of Southeast Asia, getting into India. And take a look at Australia as well. I just wanted to show you that kind of global thing real quick before we wrap this one up. So, you know our thought process. I'm going to come back to you with another video on Friday. Matt's going to do tomorrow. We're going to keep building this out and just trying to understand if these risks are real or not. But this next 30 days is going to be critical in determining the success of Northern Hemisphere crops going into summer. So we'll get there soon. I appreciate your attention. Thanks.